Welcome to Spaceverse, your portal to cosmic adventures. The vastness of the universe is difficult to grasp, but what's even more astonishing is that just 90 years ago, humanity had little understanding of its true scale. In the early 20th century, most astronomers believed that the Milky Way contained all the stars in existence. The idea that countless other galaxies could be scattered across the cosmos was unimaginable. However, a series of groundbreaking discoveries would soon change our perception of the universe forever. In 1917, astronomer Heber Curtis observed a nova, an explosion that briefly makes a star shine far brighter than usual within what was then called the Andromeda Nebula. Typically, novas fade over time, but something about this one caught Curtis's attention. Curious, he examined photographic records and found 11 more novas within Andromeda. However, these novas appeared much fainter than those seen in the Milky Way. This subtle difference led Curtis to a bold conclusion: Andromeda was not just a cloud of gas within our galaxy, but a distant system of its own. By calculating its distance, he estimated that it lay around 500,000 light-years away, far beyond the Milky Way. This supported the island universe's hypothesis, the revolutionary idea that the universe was filled with countless galaxies, each independent and immense. Despite this discovery, many scientists, including Albert Einstein, still clung to the belief that the universe was static. In fact, Einstein had even introduced a cosmological constant into his equations to maintain this assumption. However, this notion would soon be challenged by Edwin Hubble, whose observations in 1928 provided the final piece of the puzzle. By measuring the movement of galaxies, Hubble discovered that they were all moving away from us, meaning the universe was expanding. This revelation led to an even more profound realization: if the universe was expanding outward, then at some point in the past, it must have been much smaller, perhaps even a single point. This discovery laid the foundation for the concept of the Big Bang and suggested that the universe had a beginning. Using his measurements, Hubble attempted to estimate the universe's age by reversing this expansion. His initial calculations suggested that the universe was only about 2 billion years old, a figure we now know to be far too low. Today, thanks to advanced astronomical techniques and observations from telescopes like Hubble and James Webb, we have a far more accurate estimate. The universe is approximately 13.8 billion years old. The journey to understanding the age of the universe has been one of the most remarkable scientific adventures in history. What began as a simple observation of a single nova led to a radical shift in how we perceive our place in the cosmos. From the realization that we are just one of countless galaxies to the discovery that our universe has been expanding for billions of years, these breakthroughs have reshaped humanity's understanding of existence itself. The discovery of cosmic microwave background radiation in 1965 provided the final confirmation that the universe was indeed expanding, effectively settling any lingering doubts. However, while scientists were certain about the expansion, determining its precise rate remained a challenge. For decades, estimates of the universe's age varied widely, ranging anywhere from 8 billion to 18 billion years, fueling intense debate among astronomers. The problem became even more puzzling when researchers calculated the ages of the oldest main sequence stars and found that some were older than 8 billion years. This presented a major paradox: stars could not possibly be older than the universe itself. With no clear resolution, cosmology hit a dead end. Then came the Hubble Space Telescope, which in 1997 made a groundbreaking discovery that reshaped our understanding of the universe. Instead of expanding at a steady rate, the universe was actually accelerating due to a mysterious, repulsive force now known as dark energy. By incorporating dark energy into expansion models, astronomers were finally able to resolve the age discrepancy, arriving at the now widely accepted estimate of 13.8 billion years. There's a major issue that continues to puzzle astronomers. The Hubble constant, a key value used to measure the universe's expansion rate, remains uncertain. According to fundamental physics and cosmic microwave background data, the Hubble constant should be around 68 km/s per megaparsec. However, when astronomers measure the expansion using actual stars and galaxies in our cosmic neighborhood, the numbers don't align. This discrepancy raises a profound question: what if our understanding of the universe's age is only partially correct? Now brace yourself for a surprising revelation. A group of stars in the Milky Way may be just as old as the universe, or possibly even older. The globular cluster M92, a dense collection of stars located about 27,000 light-years away, has been newly estimated to be around 13.8 billion years old. This makes it nearly the same age as the universe itself, which could challenge existing models and offer new insights into how the cosmos evolved. The age is right at the edge of estimates from other groups, says astronomer Martin Ying of Dartmouth College. It helps us establish a lower limit for the universe's age. After all, we don't expect a star cluster to form before the universe, right? Globular clusters like M92 are tightly packed groups of stars that likely formed at the same time, making them valuable tools for astronomers trying to determine stellar ages. The life cycle of a star depends on its initial mass. Larger stars burn through their fuel quickly and die young, while smaller stars can last for billions of years. By analyzing how many stars in a cluster have moved past their primary fuel burning stage, scientists can estimate when the entire cluster was born. However, these age estimates traditionally rely on certain assumptions about how stars evolve. To improve accuracy, astronomer Martin Ying and his team took a different approach. Instead of relying on a single model, they used a computer to generate 20,000 simulated star populations for M92, each with a different potential age. By comparing the brightness and colors of these synthetic clusters with real observations from the Hubble Space Telescope, they pinpointed the age that best fit the data. Unlike previous studies that used only one simulation, this method significantly reduced uncertainties, cutting them down by 50% and provided a more precise estimate. Their findings suggest that M92 is about 13.8 billion years old, with a margin of error of roughly 750 million years. Interestingly, this aligns closely with the estimated age of the universe itself, which is just over 13.8 billion years, with an uncertainty of only 24 million years. This striking similarity raises intriguing questions about the universe's early days and how globular clusters fit into the grand cosmic timeline. One possible way to resolve this cosmic dilemma is to reconsider the age of the universe itself. As one researcher put it, if we take the Hubble tension seriously, then we also have to admit that our knowledge of the universe's age might not be as precise as we thought. This brings renewed attention to a recent study from the University of Ottawa, which challenges the widely accepted age of 13.8 billion years and proposes a staggering new estimate of 26.7 billion years. The study highlights the existence of stars like Methuselah, which appear older than the universe's standard age, as well as surprising discoveries made by the James Webb Space Telescope. Observations of galaxies just 300 million years after the Big Bang reveal structures that seem too mature and massive for their supposed age, posing a major puzzle for cosmologists. With advancements in computational power, improved theoretical models, more precise distance measurements, such as those for M92, and JWST's discovery of ancient galaxies from the so-called Dark Ages, new questions are emerging. Could it be that the universe is actually older than 13.8 billion years? Do we need to rethink our approach to cosmology? Renowned physicist Michio Kaku anticipated this debate, suggesting that our current estimate of the universe's age might not hold up under new evidence. When asked how this would impact our understanding of the cosmos, Kaku admitted, "That's the problem. The James Webb Space Telescope is shaking things up. Suddenly, we may have to rewrite all the textbooks about the beginning of the universe. It takes billions of years for a galaxy like the Milky Way, home to 100 billion stars, many of which are ancient, to fully form." Yet the James Webb Space Telescope has detected 6 massive galaxies that existed just 500 million years after the Big Bang, some up to 10 times larger than the Milky Way. This defies our current understanding of cosmic evolution. There shouldn't be primordial galaxies of such enormous size so soon after the universe's birth. Clearly, something doesn't add up. We may need to rethink our theories about how the universe was formed. And that's it. The universe may be 13.8 billion years old, or maybe even older. With galaxies that shouldn't exist and stars that challenge our understanding, the cosmos keeps rewriting its own story. What mysteries will we uncover next? Stay curious, stay amazed, and keep exploring with Spaceverse. See you in the next journey across the stars.